Hello all, welcome to the lecture on the case study. So, in this lecture we are going to look at a case study called classifying personal income, where we are going to see how to solve that problem using Python. So, let us look at the problem statement of the case study that we are going to solve. Subsidy Inc. is a company which delivers subsidies to individuals based on their income, and accurate income data is one of the hardest piece of data to obtain across the world. So, they have obtained a large set of data on individual income, demographic parameters and based on few financial parameters. So, they wishes us to develop an income classifier system for individuals. The main objective of the case study is to simplify the data system by reducing the number of variables to be studied without sacrificing too much of accuracy, so that the data collection part would be easier. If we have very few parameters that needs to be measured, then the data collection part will be easier. So, that such a system would help subsidy income in planning subsidy outlay, monitoring and preventing misuse. Let us quickly look at the variables that are available in the case study that we are going to solve. The first variable is age, which represents the age of the individual in years. Next one is a job type, which represents the working status of a person, which sector does he work in, like federal government, local government and so on and so forth. Next is the educational type, the level of education like 10th, masters, doctorate and so on. Next one is the marital status of the individual, whether a person is married, divorced or never married and so on. Next one is the occupation, the type of work the individual does, whether the individual is working in an armed forces or sales or technical support, and you have 11 more categories like that. Next one is relationship of the individual to his or her household. The next one is the race, it is being represented by black, white and 3 more. Next one is the gender, the individual's gender being represented as male and female. The next one is the capital gain, the capital gains of the individual basically from selling an asset such as stock or bond for more than the purchase price. Next one is the capital loss, the converse of that, the capital losses of the individual from selling an asset such as a stock or bond for less than the original purchase price. Next one is the hours per week, the number of hours that the individual works per week in a company. And we have native country of the individual being represented with like categories like United States, with countries like United States, Cambodia, Canada and so on and so forth. Next one is, the last one is the salary status, which is the outcome variable. The outcome variable indicating whether a person's salary status, whether it is less than or equal to 50,000. So, it has basically two categories, less than or equal to 50,000 and greater than 50,000. So, this is the overall idea about the problem and the description of the variables. Now, we are going to go back to Spider and we are going to see how to solve this problem. So, now let us start by importing required packages. To work with data frames, we are going to import pandas as PD, and to perform any numerical operations on it, we are going to import numpy as NP. Followed by that, we will be visualizing the data using the Seaborn library. So, we are going to import Seaborn as SNS. Followed by that, we are going to import train test split from the package called sklearn, and the model selection is a sub package under sklearn. So, we are going to import train test split from sklearn package. After that, we are going to import logistic regression from sklearn linear model. And to look for performance metrics, we are going to import accuracy and confusion matrix from sklearn metrics. So, now we have imported the required packages. Now, let us import the data into Spider. So, income is the file name and it is in CSV format. So, now let us import the data into Spider. Income is the file name and it is in CSV format. We are going to read that. and we are storing it onto a data frame called data underscore income. So, once we read the data, you can see it under the variable explorer. So, the data underscore income is of data frame and the size of the data frame is 31,978 observations with 13 columns. After reading the data, we are going to create a copy of the original data, so that original data frame will not be touched and further analysis will be made on the copied data frame. So, we are going to create a copy using .copy function and we are storing it onto a data frame called data, new data frame now. So, now we have read the data, now it is time to explore the data to understand the data even more better. So, under exploratory data analysis, we are going to broadly look into 3 topics. The first one is getting to know the data, where we basically see what type of variables that we are going to deal with. The next thing that we are going to see here is data preprocessing, where we are going to deal with missing values, like how to identify the missing values and how are we going to deal with that. And after that, we are going to understand the data through visualization and cross tables, because we will be looking into checking the relationship between the variables using cross tables and data visualization. So, basically once we read the data, we would be interested in getting the data type of each variable, so that it gives an idea about what type of data that we are going to deal with. So, .info command on a data frame gives you the data type of each variables, but if you check here, all the variables are read with expected data type, because age is read as integer, job type, from job type to gender it has been read as object, because those have only categories to it, and capital loss, capital gain, hours per week have been read as integer, because those variables have numerical variables, and the salary status, native country has been read with object data type, because we know that there exist categories under that variable. So, it has been read as object. So, now we have seen what are the data types of each variables, and we know that all the variables are read with a proper and expected data type. So, now we will check whether there are any missing values in the data frame using isNull function. So, let us check whether there are any missing values. So, basically isNull returns Boolean values, that is true and false. True indicates the missing data and the false indicates there are no missing data in a particular cell. But if you see the output, it will be difficult to skim through the whole output. So, let us take the sum of missing values in each column, so that we will get an idea about how many values or how many cells are missing under each variable. So, this can be done by adding .sum to the existing command. So, let us see how to do that. So, this is just a print statement, but the actual command is here, data.isNull.sum. So, if you execute this line, you will get an output which says no columns have missing values, because the corresponding values of each variable are 0. So, it represents that there are no missing values under any of the variables. So, now we have checked whether there are any missing values in our data frame or not. Now, it is time to understand the data by getting the descriptive statistics out of it. In our data frame, both numerical and categorical variables are there. So, the descriptive statistic can give you great insights into the shape of each variable. So, the describe function can be used to get the basic descriptive statistics out of data. So, I am going to use the .describe function on a data frame data, and I am storing that output to an object called summary underscore num, because by default the describe function gives you 8 statistical properties of numerical variables. The first one being count, mean, standard deviation, minimum, 25%, 50%, 75% and the maximum value. Basically the count represents the count of observations under the particular variable, that is age. When we look at the mean of age, the average age of the individual is turned out to be 39 years and the standard deviation is around 14, and the minimum age of the individual is 17 years. The next is 25%, that is 25% of the individual's age is less than 28 years. The next is 50%, the median age is 37 years here. Next is 75%, 75% of the individual age is less than 48 years. At last you have maximum value. We know that at the max the age of the individual is 90 years. Similarly, if you look at the capital gain, it is a profit from the sale of property or an investment. So, whether the sale price exceeds the purchase price. So, if you look at the capital gain, it is a profit from the sale of property or an investment where the sale price exceeds the purchase price, then only we call it as a capital gain. If you see, on an average the capital gain of the individual is 1069 and the standard deviation is really high, that is 7298. And if you look at the maximum value, it is 99,999, but the minimum value is 0. So, in this case it turned out that only 25% of the capital gain is greater than 0. That is why you have nothing under from minimum to 75%, because it is very evident that very few people will be investing in stocks or in any other investment, so that they get some profit out of it. So, conversely, a capital loss arises if the proceeds from the sale of a capital asset are less than the purchase price. It is turned out that only 25% of the capital loss is greater than 0. Though the maximum value is 4356, the minimum value is still 0. So, similarly, you can look at the spread of the hours per week. Like on an average, individual spends 40 hours per week in a company. Similarly, you can look at the other statistics. And we also have categorical variables in our data frame. On that note, we would be interested in getting the frequencies of each categories under a variable. So, the same command is being used by setting include is equal to O. O represents object. So, let us see what the output gives us. And we are storing that onto an object called summary underscore CATE that represents summary for categorical variables. So, basically when you set include is equal to O, it gives you 4 measures starting from count. Count basically gives you how many observations are considered while giving you the summary. And then unique represents how many unique categories are available under that particular variable. For example, under job type we have 9 unique categories. And next is the top, which gives you the modal value of the variable, that is the most frequently occurring category. So, for job type the most frequently occurring category is private, and you can also get the corresponding frequency. Here 22,286 observation corresponds to private category. Similarly, you can look at the frequencies of the categories that are available under other variables. But from this output we now just know how many unique values are there, but we would be interested in getting the unique categories under a variable, so that it gives us an idea what are the categories that are there in a particular variable. So, for that case, in that case the value underscore counts gives us the better representation. So, let us see how to use the value underscore function. So, I am just going to take the first variable, that is job type. I am going to get the frequencies of each categories that are available under job type. So, basically this gives us the better representation by listing all the available categories and the frequencies. If you look at here, it basically gives you the frequencies of each categories under job type. You can also see there exists question mark instead of nan. So, there exists a question mark instead of nan because by default Python only reads the blank cells as nan, not other special characters. In this case we have a special character, but it is not being read as nan, but we have encountered that there are some missing values in the form of question marks. Similarly, we can also get the frequencies of categories using the value underscore counts for other variables, but it turned out that occupation also has question marks here. But when we looked at the data, there were only question marks under two variables, that is occupation and job type. So, to basically see how exactly the special characters are, we can use the unique function. So, let us check the unique classes of job type. So, basically unique function is from NumPy library, and inside the function I have specified the job type from data frame data. So, if you see that there exists a special character which is question mark, there is a space before the question mark. This is how exactly the levels of the job type are being entered. So, if you see here, before the starting letter of the every level, there is a space in front of it. So, similarly, we have a space in front of question marks also. This is how exactly the special character is being entered here. So, now we know that there are some special characters which is just the representation of missing values. So, what we are going to do here is we are going to go back and read the data by including the NA values to consider the special character as none. By adding NA underscore values with a list of string values, we are going to consider the special character as none values. So, once we have executed this data, you will be able to see the data frame size is 31,978 observation with 13 variables. Now, we have seen how to consider other special characters as none values. Now, it is time to pre-process the data. Basically, now we know that there are some missing values in a data frame. To deal with the missing data, we need to first identify the missing data and then we can examine the missing value pattern. So, by using the same isNull function, we found out that 1809 cells are missing under job type and 1816 cells are missing under occupation, and no other variables have missing values except job type and occupation. So, before deciding on how to deal with the missing data, let us see in a particular row either one of the column is missing or both the column values are missing. For that, let us subset the rows at least one column is missing in a row. So, here we are going to subset the rows by giving dot any axis is equal to 1. So, that it considered at least one missing column in a particular row. Now, if we have subsetted the rows with missing values, if you look at the size of the data frame, it is 1816, it is with 1816 rows with 13 variables. So, now let us open the missing data frame and inspect the missing data. So, it is very clear that wherever job type is missing, the occupation is also missing, but the total number of missing values is 1816 rows. So, there is a special category called never worked and the corresponding value of the occupation is none. Since the job type is never worked, so if you sort the job type, there is a category called never work. If the individual has never worked, then occupation could not be filled. That is the reason you have none values under occupation. So, now let us go back to the scripting window and see and what we are going to do with it. So, let us quickly note some points that we have got from the missing data. So, missing values in job type is equal to 1809 rows. So, there are 1816 rows that are missing under occupation and there are 1809 rows where two specific column, that is occupation and job type, have missing values. So, there is a difference between 1816 and 1809, that is 7 rows. You still have occupation unfilled for those 7 rows because job type is never worked. That is why the total number of missing values is 1816. Now, in this case we can delete the cases containing the missing data or replace the missing values with reasonable alternative data values. If the data are not missing at random, we have to model the mechanisms that produce missing values as well as the relationship of interest, which is very complex in this context. So, here we are going to remove all the rows with missing values and consider only the complete cases alone. So, in that case we are going to use a command called drop NA, and by setting axis is equal to 0, we are dropping out all the rows wherever there are missing values. So, if you look at the size of the data 2 data frame, that is 30,162 rows with 13 variables. That means that we have gotten rid of 1816 rows wherever there were missing values. Why? Because we could not find out the mechanism that goes behind which produce the missing values, and we do not know the relationship of interest as well. So, we are going in this session we are going to remove all the missing values and we are going to continue with the further analysis. So, with complete cases, let us look at the relationship between numerical variables, that is between independent variables, using the correlation measure. So, you can get the correlation, you can get the pairwise correlation using the dot cor function. Using the cor function, so, and I have said my output to a variable called correlation onto an object called correlation. So, let us look at the correlation values. So, if you look at the correlation values, none of the variables correlation, so none of the values are nearer to 1, most of the values are nearer to 0. It represents that none of the variables are correlated with each other, because the correlation values lies from -1 to +1, and if it is closer to 1, we say that there is a strong relationship between two variables, and if it is closer to 0, then we say that there are no or little correlation between variables. So, in our case none of the variables are correlated with each other. So, now we will consider the categorical variables to look at the relationship of it. So, now we will look at the gender proportion using the cross table function. So, here I am accessing the columns of data 2. Basically, it gives you the column names of each variable, so that you can use the column names in the further analysis. So, here we are going to look at the gender proportion using the cross table function, and by setting normalize is equal to true, you will get the proportion table, and you will give the variable of interest under the index column. And let us look at the output now. If you see here, male are high in frequency, that is 67% corresponds to male and only 33% corresponds to female. So, now we have got an idea about what is the proportion of gender that we have. Now, it is time to check how salary status varies across gender. So, we are going to look at the two-way table, where we are going to check the relationship between gender and salary status, and in a row I want gender, and in columns I want, and in rows I want gender, and in columns I want salary status. And by setting normalize is equal to index, I am going to get the row proportion equals to 1. So, from the output it is very clear that only 11% of the female earn greater than $50,000 and 89% earn less than $50,000, but men are more likely to earn more than when compared with women. On classification problems, you need to know how balanced the class values are. For example, you need to know the proportion of your output variable. So, let us visually look at the frequency distribution of the salary status using the count plot function from Seaborn, and the variable of interest is salstat, because we are going to look at the bar plot of salary status. So, it is very clear that around 75% of the observation corresponds to less than or equal to 50,000 and only 25% corresponds to greater than 50,000. So, now let us plot the histogram to check the underlying frequency distribution of the age variable. So, I am going to plot a histogram using this plot from the Seaborn library and for the age variable, and by setting bins is equal to 10, I will have only 10 bins to interpret from, and I am setting KD is equal to false, so that I will have the frequencies on the y axis. So, from the histogram it is very clear that people with age 20 to 45 are high in frequency, and we also have the records for the other ages, but between 20 to 45 the frequency is high. Similarly, we can generate cross tables and plots to understand the relationship between other variables. So, if you want to do a bivariate analysis to check how age is affecting the salary status, then we can do a box plot to check how salary is varying across age. So, people with 35 to 50 age are more likely to earn more than 50,000 US dollars, but people with 25 to 35 age are more likely to earn less than $50,000. So, similarly, you can generate the cross tables and plots to understand the relationship between other variables. Using Python, we have looked at the relationship between the variables using cross tables and visualization. So, now I am going to quickly take you through the exploratory data analysis through slides, where I am going to show you the relationship between variables using the same commands that we have used in the Python. So, first we are going to look at the job type versus salary status. So, first we are going to look at the relationship between job type and salary status. So, here is the bar plot, which gives you an idea about what is the count, what is the frequency of each categories that are available under a job type. So, for example, if you see here, most of the individuals work in a private organization and very few work in the state government or federal government organization. This is the frequency distribution of the job type, but if you want to see how salary is varying across the job type, then we can look at the cross table, and I have highlighted only a single row which will give you an idea about what is the percentage split for an individual. If he is self-employed, then what is the percentage split that he will earn greater than 50,000 or less than or equal to 50,000. For the greater than 50,000, it turned out to be 56%, and for the less than or equal to 50,000, it is 44%. And for the rest of the job type, more or less 70% of the individuals earn less than or equal to 50, and the rest of the percentage belongs to greater than 50. Only for the self-employed people, there is an equal proportion, more or less equal proportion for both the categories. And on the whole, from the above table, it is visible that on the whole, if you look at the job type, it will be an important variable in avoiding the misuse of subsidies. So, next we will look at a variable called education. Let us just look at the frequency distribution of education. Education basically has too many levels to it, starting from preschool to doctorate, and if you look at the frequencies of each categories, only the higher secondary graduation has the highest frequency. Most of the people have finished their higher secondary graduation and followed by some college. And if you see here, the blue bar is the representative of less than or equal to 50 and greater than 50. So, now let us look at the relationship that exists between the salary status and education to see how the salary status is varying across the education type. So, we are going to use the cross table for that. So, from the table we can see that people who have done doctorate, masters and professional school are more likely to earn above 50,000 US dollars per year when compared with the other education type. So, that and hence it can be an influencing variable in avoiding the misuse of the subsidies. Next, we will look at a variable called occupation. This is the bar diagram of the occupation variable. And if you look at the categories under the occupation, it has so many to it, starting from administrative, clerical, and it has so many categories like armed forces, farm, fishing, technical support and other services. If you try to interpret how salary status is dependent on occupation, then there is a clear demarcation because there is no equal length of bars for both the colors, like for less than or equal to 50 or greater than 50. For each and every level of the occupation, the salary status, the proportion or the frequency of salary status is differing. So, let us get a clear idea using the cross table. So, here is the cross table for occupation versus salary, so that we will get an idea whether the salary status is dependent on occupation or not. So, from the output I have highlighted two levels here, one is executive managerial and the other one is preprocessing. So, I have highlighted two levels, one is executive managerial and the other is prof specialty, and those who make more than $50,000 per year are more likely to work as a managers and professionals. Hence, it can be an important variable in avoiding the misuse of subsidies. So, let us see how this variable is impacting the salary status when we build the model. Capital gain is one of the variable that we have from the data frame, which is an important variable, because if the capital gain of the individual is high, then the salary status could be high. So, this could be one of the important variables to classify the individual's salary status, and the plot shows the frequency distribution of the capital gain variable. Though the capital gain is ranging from 0 to 1 lakh, but there are more observations in between the bins 0 to 20,000. So, that means 92% of the capital gain is 0, which corresponds to 27,611 observation, and only 8% of the people have gained something from selling their asset or have gained profit out of their investment. So, this could be one of the important variable to classify the individual salary status. So, let us see whether capital gain is an important variable when we build the model. Capital loss values are also ranging from 0 to 4,000, but 95% of the capital loss is 0. So, in our records, either we have the records for capital gain or loss, because either they have lost or gained from the investment. And if you see 28,721 individuals capital loss is 0. So, either they would have not invested or the capital loss is 0 for them, or the capital loss is still 0. That could be the reason, because they have not invested or they have not lost anything from their investment. So, let us see whether this will be an important variable when we try to include this in a model. The next one is the hours spent variable. So, the plot shows the relationship between the salary status and hours spent using the box plot. On the x axis I have the salary status, on the y axis I have the horsepower, and on the x axis the salary status is represented as greater than 50 and less than or equal to 50. And the plot shows the relationship between that exists between the hours spent and the salary status. Here we are going to check how the salary status is varying with respect to the hours spent by the individual in a company. And if you see here from the plot, it is clearly visible that those who make more than $50,000 per year are more likely to spend between 40 to 50 hours per week on an average, and this variable can contribute in classifying the individual salary status, since there is an association between salary status and hours per week. Because when you consider the less than or equal to 50,000 category, the median is very low when compared to the greater than 50,000 category, and the minimum hours spent and the maximum hours spent by the individual is also very low. That could also be the reason, that is why they are earning less than $50,000 per year. But all these interpretations that we have made are from the data that we have. It might differ it with respect to different sets of data.